In 5.2, we're going to do these three things. We're going to look at the probability distribution of a discrete random variable, and we're going to make a histogram for it and describe its shape. Remember, skewed right, skewed left, approximately symmetrical. We're going to calculate and interpret the mean, which is also called the expected value of that discrete random variable. And we're going to calculate and interpret the standard deviation of that random variable. Okay? So first, let's look at something we did yesterday. We looked at the APGAR score, right? So X is the APGAR score of a baby. Remember, they have a score from 0 to 10. These are the probabilities of those things. To create a histogram for this, we need to, this is how we do it. So the scores could be a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, a 8, a 9, or a 10. Okay? And then here we have the distributions, go from there all the way up to, what, 40, okay? So I'll go 5%, 10%, 15, 20, 25, 30, 35, this is what I'm doing, 40, 45, okay, the highest was 43, okay, so up to 45 is good. And then you just want to make a histogram out of it. So at 10 it was 0.05, okay, so it would be about there. At 9, 43%, so that's one that goes way up there, okay. At 8, 32% would be about there, okay, so etc. So this is what that should look like at the end, okay. So you have the score and their probabilities. Remember how we described the distribution? Remember how we thought SOCs? Okay, the first one was the shape. Okay, that's we want to focus on the shape for today. We'll also talk about center and spread. The center, we're going to talk about standard deviation today. I'm sorry, center, we're going to talk about the mean today, which is also called our expected value. And we'll also talk today about the standard deviation of this shape as well. Okay, of this distribution. The shape, remember, was skewed left or right. It was uniform, which we didn't really use much, or approximately symmetrical. Okay, and by looking at this one, it goes like this. Okay, so this one is skewed left. Okay. Okay, let's look at another problem here. Peach Jeep Tours offers a popular half-day trip to a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. He charges $150 per passenger. C is the total amount of money that he collects on a random trip. So the probability distribution is this. Okay, total collected 300. Okay, that's 2 people, right? 15% of the time. 3 people, 4 people, 5 people, and 6 people. Okay, so if we make a histogram out of this, we have $300, 450, 6. Okay, so those are our discrete categories, and then our probabilities. This one happened 15%. This one happened 25%, etc. Okay, so describing it, it's roughly symmetrical. Not exactly symmetrical, but roughly symmetrical, and it has kind of a middle, a single peak here at 600. Okay, so the next thing we're going to do is we're going to talk about the expected value, or the mean. Okay, so by looking at this distribution right here, we could kind of think the mean is probably, you know, somewhere in this area, right? There's a few more data on this side than this side, so it's probably, you know, leaning towards this area right in here, probably like 550, or I don't know, something like that. Okay, but this is how we figure it out. Okay, the expected value. Okay, so here are those probabilities again. So C is the probability. Okay, so what we do, the mean. This is the symbol we use. So we say the mean of our variable. Okay, C was our amount of money, right? We take this 300 and multiply it by the 15. Then we add to that the 450 times the 0.25. And we add to that, and we just keep going. Okay, and if I work this out, okay, I want to find the average of this, and that's divided by 100%. Actually, no, you don't need to do that part. Sorry, this is just what you do. Okay, that times that, plus that times that, plus that times that. Okay, so if I work that out, 300 times 15%. Yeah, anyway, I won't work that out for you, but you can work that out, and it comes up to be $562.50. Okay, so that is the mean. Okay, think about what mean is. Mean is the average, right? So we found the average. So the average of how much he brings in every time, right? The middle number right here, the mean, okay, is going to be $562.50. Remember, we take that times that, plus that times that, plus that times that, etc. Okay, this is the kind of formula for that to find the mean or expected value. So let's talk about what expected value. Okay, we call it expected value because if he'd take many trips, right? If Pete's tours took many trips, the average or expected amount he would get, kind of average per trip, would be $562.50. Okay, so it's kind of weighted there. Okay, so this is the language for it. The expected value of x. You take x times p plus x times p plus x times p, right? So it's a sum of x times p. You don't really need to know that notation, just know how to find it. Okay, so we can see right here, that point right there is that money collected. Okay, so this is kind of the words you would use to describe it then. On the tour, we know that the mean of the cost of money that he's bringing in was this much. So how do you interpret this? We would say, if we randomly select many Jeep tours, he will make about $562.50 per trip on average. Okay, per trip on average. Okay, so next problem. The APGAR score. Earlier we defined the random variable x as the APGAR score, etc. Find and interpret the expected value. Okay, so remember we would take the expected value of x in this case is 0 times 0.001 plus 1 times 0.006 plus 2 times 0.007, and you would keep going all the way up to 10 times 0.053. Okay, and if you figure all those out together, work them all out, it comes up to be 8.128. Okay, so what does that mean? Okay, think about, pause the video and think about what that means. So the expected value of 8.28. So notice, I mean, we had talked about a random variable being a discrete random variable being a set number, right? Not a continuous number. That doesn't mean that our mean can't be this. Okay, so we can have, this is a possible. It's not a possible APGAR score, but it can be a mean of an APGAR score. So our mean can be something other than discrete sort of idea. Okay, can we find the median of a discrete random variable? Remember, median is the midpoint. Okay, so it'd be halfway between. So we know at the 50th percentile, so 50th percentile would be somewhere in this category, right? So 25 and so 50% would be in this category, so we know it would be 600. Okay, next we're going to talk about standard deviation. So if you remember standard deviation back from chapter, 1, I guess, standard deviation is how spread out the data is, right? The smaller the standard deviation. So if we use a standard deviation of 2 versus a standard deviation of 20, okay, standard deviation of 2 means we have our data that's pretty close all together. 20 would mean that it's very spread out. Okay, so smaller standard deviation, closer together. Okay, so if you remember how we find standard deviation, this is what we did the other chapter, right? We found a variable minus the mean squared plus another minus the data number minus the mean squared, and we kept doing it for all of them, right? So we're going to modify this approach for standard deviation of the random variable. Basically, I'm just going to kind of show you how you do it. Okay, this kind of gets into how you do it, but you're going to take this number minus the mean squared times the probability. This number minus the mean squared times probability, plus this number minus the mean squared times probability. Okay, so if we think about this, this is the Jeep collection again. So Pete's Jeeps. Okay, so if we take 300 collected, right, minus the mean that we found earlier squared, we multiply it by the probability. Then we take the next one, 450, minus the mean squared times the probability. And we do that for all of these and add them all up together, we get this. Okay, that's called the variance. Then remember, we have to take the square root of that number yet. Okay, so if we take the square root of this number, we get $163.46. Okay, so interpretation of that, the amount of money that Pete collects on random selected day typically differs from the mean of this by about that much. Okay, it typically differs from the mean from that much. Okay, so if we do that for the APGAR scores here, okay, so for the APGAR scores, we would take, remember our mean was 8.128, right? So 0 minus 8.128 squared times the probability, plus that minus the mean squared times the probability. And you want to do that for all these here. 2 minus that squared times this. Okay, do it for all these all the way through 10 minus this squared times the probability, and then take the square root of all that number. Okay, so in interpretation, a randomly selected baby's APGAR score 1 minute after birth will typically differ from the mean by about 1.4 units. Okay, so here's where you get to practice. Okay, so remember our grades, so F, D, C, B, and A, right, on a 4-point scale. I have this distribution. Okay, so I want you to pause the video and do these three things. Make a histogram, calculate and interpret the mean, calculate and interpret the standard deviation. Okay, for my histogram here, 0 happened only 1% of the time, so that's going to be pretty low. It's even lower than that anyway. And 1 happened 3% of the time, so 1 a little bit more, but still not much. 2 happened about 14% of the time. 3 was 36% of the time. And 4 happened almost 45% of the time. Okay, so there's my histogram for part A. Okay, for part B, I want to find the mean. Okay, so remember to find the mean, we have to take the mean of what variable we're using. X is the, okay, mean of X is 0 times 0.011 plus 1 times 0.032 plus 2 times 0.138. That sun's getting in the way. Let me move everything. Plus 3 times 0.362 plus 4 times 0.457. Okay, so it should look something like this. We have to put this in the calculator and work this out. Okay, I just put all that in the calculator here, and I get 3.222. Oh, nope, I did it. Yes, I did it right. Yep. Okay, so I know that the mean of X is 0.3. Okay, then part C, oh, I have to interpret that. Okay, the average, if I pick a random student, if a lot of random students, are selected, their average grade score would be 3.222. Okay, so I just picked a bunch of random students, find their mean. I would expect to have a mean about that. Okay, so part C is to find the standard deviation. Okay, so to find the standard deviation here, remember it's the square root of 0 minus, our mean was 3.222, squared times its probability. I have to do that for all of them. 1 minus 3.222. Gets a little tedious here. And one more. Whoops. Okay, so that would be what it is. Okay, we got to put this in the calculator and work this out. Okay, so I'm going to pause it and put it in. Okay, one thing I noticed when I forgot to put the squares there when I wrote it before. Put those squares there. If you put this in the calculator, you get this. So we have that our standard deviation of C is equal to 0.774. Okay, so we would say the grade typically differs from the mean, and the mean was 3.4222, by about 0.774. There is a way that you can find these if you have a TI-83 or 84 calculator. You can put the numbers into L1 and the probabilities into L2. And if you do the one variable statistics, you can put L1 into Y1 and L2 into Y2. And you can do you can do it that way. Read the textbook if you want to do that. Most of you don't have the calculators to do that though. Okay, so we did 3 things today. We made a histogram, and from that histogram we thought about how we think about from a histogram we used to think socks, right? Shape, we talked about shape, we talked about center, and we talked about spread today. Okay, so talking about describing the shape, the center is the mean, and the standard deviation is that spread, and how we find those.